Welcome back. We're on to our next topic point for the revolutions unit. And so today we're going to talk about technology of the Industrial Revolution. So there are no essential questions again. So don't answer them, but make sure you pay attention and get some information out of this. This is a very short one, so I'm trying to keep it as simple as possible with giving you as much detail as you need to help answer questions and be able to write information on your essays. So the development of machines, including the steam engine and internal combustion engine, made it possible to take advantage from both existing and vastly newly discovered resources of energy, including stored fossil fuels, specifically coal and oil. And the fossil fuels revolution greatly increased the energy available to human societies, a consequence that we'll probably pay for later, but it is certainly something that defines the revolutions that do happen. You need something to power it, right? So the first industrial revolution, there's two industrial revolutions that you need to be aware of. There's a first and a second. So there's a distinguishment between the two. The first one is going to be fueled by coal and iron. So James Watt is going to invent the steam engine, which will end up harnessing the power of burning coal, which would then create the pressurized steam that moves mechanisms for the machines. And this is really important for lots of reasons. First of all, factories can be built anywhere at this point. No longer did they have to be next to rivers or streams that flowed fast enough to be able to move the mechanisms inside the factory through the catching of a water mill. But now it is going to be something of you can build them pretty much everywhere. It also helps improve technology and transportation, especially for transportation. Railroads, steamships are two major technologies that rely on steam engines to be able to move them. And when you have this type of technology, you're able to move more people, more goods all over the world, wherever you can make them go, right? And coal also plays a massive role in helping produce and mass produce iron production. So iron, while it's not as strong as metals that are used later, in particular steel, it does help create more building, especially like things like bridges. Of course, iron is going to be used in a lot of technologies and building materials moving forward and such, up until the moment where it gets replaced by a better material. Oops. All right. So the second industrial revolution, though, that led to new methods of production, steel, chemicals, electricity, and precision machinery during the second half of the 19th century. So we're going to talk about some of the illustrative examples here, starting with the Bessemer process, okay? And the Bessemer process, let me get myself out of the way here. The Bessemer process is something that is going to help increase steel production. Now, steel is something that has been around for a long time, but you can only produce so much of it, and it required a lot of energy and specialized artisans to make it possible. However, the Bessemer process makes it much more of a product that can be mass manufactured. The more of it available leads to the availability and making it cheaper. And so steel itself is going to, become something that will help build the second industrial revolution. And so things like navies, today, skyscrapers, they rely on steel as a product to be able to build them. Okay, so the Empire State Building in New York City, one of the more famous tall buildings in the world, the whole frame is steel, and it's such a strong material that will not rot. Like iron had all these impurities over it, so that it would rust over, and over time, pretty much get to a point where it's weakened and no longer safe to be used as a building material. But steel doesn't. And so how this Bessemer process works, and if you're staring at this whole GIF, I understand, but bear with me for a minute, okay? But you put the raw materials into this giant furnace. So you need pig iron, you need lime and other things. And so when you tilt it up, you blast hot air into here, which then would kind of lead it to be really, really hot. That would burn off any impurities that would cause rusting in iron and so forth. And then by the time you pour it out, like what you see here in the GIF, you have molten steel, which is burns off all those impurities, and you have a very, very strong material that can be manufactured and molded into whatever you need. So, steel becomes the backbone of the late 1800s and really a big part of the second industrial revolution. So steel replaces iron by the second industrial revolution. The Fritz Haber and the Haber-Bosch process is something that's also super important for multiple reasons. But ultimately, it's a process that is able to isolate particular chemicals, nitrogen and ammonia especially. This is important because it allows the manufacturing of artificial fertilizers, something that will play a more significant role in the 1900s than it will in the 1800s. But it also leads credence to the idea of how chemicals can be manufactured. And so it's not just going to be this. The basic ideas and concepts of this would then be used to manufacture all chemicals that you can think of. So it has huge implications and impacts on future generations. And of course, still is important by today's standards because we need artificial fertilizer to be able to continue to produce food in masses like we do today, especially here in America. There's a lot of other notable technologies of the second industrial revolution, and I'm not going to go through them all. Your book will talk about some of them, but the chemical processes to help extract petroleum and kerosene from oil is big because, of course, petroleum, which we typically call gasoline, will help fuel the internal combustion engines that help move things like automobiles, ships, and airplanes. Electricity is also something that's going to be more part of the second industrial revolution, and men like Thomas Edison and Nikola Tesla, and there's much more, Westinghouse, that are going to be big in helping create electricity as a means of powering cities, factories, and so forth. They have some pretty notable inventions. Thomas Edison, of course, is most famous for the light bulb, the incandescent light bulb. And really, with that, it helps vanish the night, and you instead of having to go to bed at 4:30 because we're right in the dead middle of winter right now as I record this, you can stay up with the lights on and so forth. And, of course, Christmas is coming up and such, so you don't have Christmas lights without the incandescent light bulb. But this is something that really changes how people live. Nikola Tesla was big on the alternating current generator, AC. This is important because that's what most of the generating of electricity is in the world today. Communication is also going to improve. Alexander Graham Bell, who will invent the telephone, which replaces the telegraph that was invented by Samuel F.B. Morse back in the 1830s. But it allowed people to have actual conversations live over the phone. It changes communication in a lot of ways. And then, of course, the radio, which would be invented by Marconi, an Italian physicist. This is going to have huge implications on replacing mass media and especially in industrialized countries where people aren't reading as much as they are as much listening to radio for information. Of course, they still read way more than you guys do as a generation, but yeah. Okay. So yeah, here's in a nutshell, all this industrial technology that does come around in this time. And there's a lot, like I mentioned, and I just don't have time to talk about all these things. And I'll lose you if I go into details about each one of these. But here are some notable technologies that come out during the second and first industrial revolutions. The big difference between is industrial revolution number one is fueled by iron and coal. The second one is fueled more by oil and steel and electricity. So last thing I'm going to talk about, and I'm not going to go into too much detail about this because it's pretty obvious what they're talking about here, but railroads, steamships, and telegraphs, and later telephones made exploration and development and communication possible into the interior regions globally, which led to the increased trade and migration. So talking about the Trans-Siberian Railroad, as we did earlier, in 5.4, that railroad allows them to, people of Moscow to reach into the interior of their country, allows them to trade with East Asia. The United States has its own railroad system that we create the Transcontinental Railroad, something you probably learned about in Utah history because they meet up when that line was being built. They met up in Promontory Point, Utah, which is up by Logan. And so these are things that are going to play a significant role in allowing them to find more raw materials and to help fuel their industry, and then more things to trade, or things to turn manufacture into, or raw materials to manufacture and then trade those manufactured goods. And it allows migration. People start moving more towards the interior of the country in the United States and within Russia. It is going to lead more migration of people around the world, including immigration, where people are coming from other parts of the world to these industrialized countries, sometimes going back. So yeah, people move much more so because of this technology than they had before. And prior to this era, the average distance that most people would travel from their birthplace is about 25 miles. But now that you have this technology that makes it possible for you to be able to buy a ticket, sit on a ship or a railroad, and then let the technology do the work for you. So yeah, it changes a lot about the world. And so increased migration will have impacts all over as a result. And it still does today. All right, that's it. I'm done. Go enjoy the rest of your day. Make sure you are taking good notes on this stuff. I have videos connected on the Canvas page that are simply for more detailed information if you wish to learn more. And I hope you do, but it's not a requirement. But the rest of the day is yours to do. Make sure you are getting your work done, and I hope to see you all later.